So good evening, everyone. This bit goes a bit against the grain. The last time I was in a lecture theatre, I was sat on your side of the desk, probably asleep in that back corner up there, really. But my name's Colin Arnold. Obviously, ex-Harper, finished here in 2007. Studied Ag-Eng marketing and management. Did my placement year with CLAAS 2005-2006. And went back to them in 2008 as a graduate trainee. I did a couple of years down at Saxham in various roles, whether parts, bit in accounts and around the business. And then in January 2011, I came out onto territory initially as a territory manager, now as a regional sales manager, covering basically the West Midlands, North Wales and the Midwest of England from a sales perspective for CLAAS, covering all products. I cover a few dealers. I've got three small tractor and green line dealers, and then my main focus is Morris Caulfield's, a local CLAAS dealer. They got 4 depots locally, from Cheshire down to Hereford. Yeah, so I give them support for sales, demonstrations, and product related things like that, really. So bit of a varied job, but yeah, Harper background, and yeah, like many of the other guys that are in CLAAS, a lot of us have come from Harper and followed through a longer term career, really. So that's me. So tonight we're going to be presenting focus on Terra tracks through our product range. So 2017-18 we sort of entered in. So traditionally the combine was the product that we had the Trak system mounted on. We're going to look at a little bit of the newer product range, and I'm joined here with Dean Crotty. He's the green harvest and forage harvester product specialist based at Saxham. So I'll let him introduce himself and then we'll go back to the presentation. So, yeah.
Hi there, good evening. Like Colin said, my name's Dean. I was also an inmate here, left in 2009, and then did my placement the same with CLAAS. To me, that's the biggest asset I left Harper Adams with, was my work experience. Work experience is worth its weight in gold. Lots of people leave with various different degrees from various different universities, but having the name Harper Adams behind it and having the experience behind it is worth its weight in gold. So I was very fortunate. I was offered my position after I finished my placement with CLAAS, came back here for my final year. The thing that was very, very comforting, especially maybe because it's a family company, CLAAS. There was many of my colleagues in 2009, and when we left Harper, had nothing, because that's when we had the big financial crisis. So various different companies all rejected the placement students, but for me it was straight back to CLAAS. Again, worth its weight in gold, especially with Harper Adams. Other friends at various different universities were really stuck. I was fortunate I wasn't. And similar to Colin, I had to do what we call a graduate training program within CLAAS. So spend various different months in departments such as parts, the tech office, the academy. I had to work in Germany for 6 months. So 4 months at Harswinkel, which is our headquarters in the north of Germany. That's where we make the combines, the forage harvesters, and the Xerion tractors. And then 2 months down in Bad Salgo, which is in the south of Germany. Beautiful area, not far from Austria and Switzerland. Good for drinking beer and skiing if you like it as well. That's the home of all our green harvest machines and forage harvester crop flow development. Again, I came back from my little graduate stint within the company to do this job, which I've been doing since 2012. So yeah, we'll go through the tracks in a bit of detail. The bit I know a lot more in detail is especially with the forage harvesters. So especially when you spend a bit of time working at the factory, or my job is almost like a liaison between a dealer and a customer and the factory. So again, you'll see these sort of jobs advertised at various different companies. A product manager, product specialist type role really is a very intrinsic link between the factory and the customer. And again, you'll see more and more of those sort of jobs appearing, especially as you see more machines get more complicated, more options, more sophistication on them. It means they get more expensive and it's harder work for someone like Cole and myself to go and sell them. So those sort of jobs are really vital to sell the dream effectively, to make sure everyone knows exactly what they're getting, both from the company and from the customer point of view as well. Cole, do you want to start?
So as we said, the focus tonight is obviously the Terra Trak system from CLAAS. So to start off with, we'll have a look at where we've come from. So really, the Trak story for CLAAS started in 1955. Started on our earlier Matador combines and so on. Really, in its infancy, the Trak was used for flotation. So for markets in places like Italy, where they grow a lot of rice. So the Trak was purely a steel track that we see on older track laying tractors. There wasn't a lot of technology in it, but it was clearly just to try and get the combine to travel on wet fields. The original half track system, so it kept the steering wheels of the original combine, and it's still something that we offer today on certain models of combine for certain markets there as well. So the steel track has stood the test of time, but really the big focus is for flotation. But there was a defined outline that we wanted to look at alternative options as far as carrying weight and so on combine harvesters. So the development moved on to a partnership with Caterpillar from their Caterpillar tractors, which you can see in the bottom of the presentation here. We basically took a Trak unit similar to what they used on the Trak tractor. 1985, the development work started. And the idea was, again, to start looking at how we carry these large, heavy combine harvesters on the fields and give benefits as far as ground compaction and so on. 1987 saw the first production machine get sold in or get shown in the US. And then in 1989, we actually, there was one shown at the Royal Show, and what was I, 6? But I can remember being there with my dad and actually seeing all the videos in the stand, and the machine was actually on display on the show stand. So, but the original concept was a 2-tracked unit, so the tracks were just bolted onto the side of the existing combine harvester. The big issue with this was its width. So the tracks units became very wide because it actually literally just had to stick over the outside of whatever was inside the chassis of the combine. So it made it very limited for as far as the benefits were for places like the UK and Europe. For America, it was great, where you can just set off down the road with 4, 5, 6 meters, whatever. Wasn't really a problem. So I think it became clear that although for American markets and some markets in the world it would be okay, the move was in 1994 to go to a half-track system. The benefit of the half-track system was that basically the existing parts of the combine, so like your clean grain elevator and your returns auger and parts like that, remained in their normal place, and really we used the front wheel space to propel the unit. The other advantage with going to the half-track system was it was effectively turning. So on the 2-track tractor, where we stop a track and use the other one to turn, we tend to get very badly rutted headlands and so on. And also, if we're raying straw rows for picking up, then we end up dragging them halfway across the field. So for us, the half-track system was the way that the development went. The initial one there has got 2 rubber tires just inside a track belt to basically run the gear, which I should imagine at the time was prone to all sorts of problems in flinty stones and so on, and punctures. So that led on to the introduction of our first production track units, 1997, about the couple of years after the first Lexion combines first got introduced. And really, we moved forward with our combine harvest development. So from going to a Lexion combine, we're starting to get up to combines that weighed 20 odd tons. And it was necessity that we needed to get some kind of track unit underneath there. So the original track, Gen 1 track, was literally just bolted onto the chassis of the combine. There was very limited suspension, quite rough on the road, yeah, not very refined really, until we moved to the 2004 when we introduced the Gen 2 Trak system. So basically the Gen 2 Trak system, and you can see it there on the presentation, the grey unit was fitted just under the chassis of the combine. It contained some rubber blocks in there, some rubber mounting blocks, so that we got some kind of suspension there on the track. Although the track unit itself was still very rigid with limited suspension and so on. We also moved to vulcanized wheels, land wheels. So again, for extra durability, for call it wear replacement and so on. And then in 2011, we moved a big step again, was to add the hydromatic suspension system to the track systems. So basically, we improved operator comfort. We improved the adaptability of the track unit. The big telltale sign is the green guard in the middle here. So that was the sort of introduction of the Gen 3 track, which hid the hydraulic units for the suspension system. Big step forward for us in terms of comfort, and also it allowed us to offer the track unit for the first time to travel at 40 kilometers an hour on the road. So so suddenly everyone's perception of a track unit is that you had to go slower. So a lot of our competitors were offering bolt-on track units, and they were limited to 25k maximum speed because of the limitations as far as comfort, and you shook yourself to pieces or they'd fall to bits. So to add this extra suspension unit in, the main track concept, so we've got the suspension anyway there up on the top right hand corner there. Basically we've got 2 suspension rams, and within the CLAAS track itself, we use a friction drive concept. So the tracks are actually tensioned hydraulically, rather than having toothed roller drives or anything. We have smooth rollers, and then we tension the tracks out against the track units, and that's, as I say, hydraulically tensioned, so the pressure remains on the track units. In most of the machines, there's a sensor in the cab, so if for any reason that we lose the tension, the operator knows that there's an issue, and we can either retension them by using some pipe work and operating the machine. We do have center lugs, so although we don't actually drive on the lugs in the center, the center lugs there are really for cornering and to keep the track in line as it goes through its through the wheels. So again, to work against the side loadings that we may see and so on. One of the concepts of the CLAAS track is that we have large diameter drive rollers. In terms of use in the field, the large roller basically gives us a lot less rolling resistance. So if we're in soils that maybe when they get deformed and so on, when it's less of a ramp for the machine to drive up effectively, so it's easier driving on the ground. And again, where you see other track units that use very small idler main drive rollers on our competitor machines. We also have a low pivot point in the center, so this aids us with as far as getting call it the drive momentum through. We don't get problems with twist from the drive shafts and so on. It gives it a low center of gravity, keeps the track nice and stable, and that's probably a common theme that will come through with some of the other products when Dean gets onto his slides as well, about how the machine travels over the ground. As I said, automatic track tensioning. We can actually, on the new Gen 3 track, we can adjust to 3 positions from the cab, dependent, so we can carry the machine at different heights. Quite useful as well if we want to go through a gateway and we need to lift the combine header over the top of a gate post or something. It gives us a few centimeters of extra clearance there. We now offer 3 different belt widths, so either 635 millimeters, which is the UK standard, up to 890 millimeters, which in the UK is quite limited, I would say, mainly because of transport width and so on. But for some markets, again, your rice markets in Italy and so on, then we do sell some of those. Compared to our non-suspended Trak system, when the Gen 3 Trak came out, we noted that shock loadings had been reduced by 30%, that the peak loads on the actual drive lines and so on had reduced by about 30%, and the ground pressure peaks had reduced as well, purely by the introduction of some kind of hydropneumatical suspension. So some big factors there. Also, some of the things like taking some of the vibration out from our earlier Trak units actually helps with the reliability of machines. There's less fatigue and so on. And some of the key concepts there is that we have a long service life. We have less wear and tear because we haven't got driven lugs and so on. They're good. There's no drive rollers for stones and stuff to get stuck in. Usually the dirt and stuff is squeezed out of the Trak unit before there's any damage done. And probably the big thing for us, and the 20 odd years of Trak development, is that it's tried and tested all over the world. And I think the number of everyone probably in the room seen a Lexion combine with a set of Traks on, really. So the combine was our focus in the early stages. I haven't focused too much on the ins and outs of the combine, but we're looking more so around the Trak systems and so on there. So back in 2006, and I was actually on placement at CLAAS when the research was being undertaken. So a guy called Dirk Ansorg was under the watchful eye of Dick Godwin, who's well known in the IAgrE. They conducted some research down at Cranfield University as part of a PhD project, which focused around the CLAAS Trak system. They got into a soil bin and basically soil tank there, and they layered it with talcum powder and layers of soil, and did a lot of research around combinations of tires and tracks, and basically looking at the various conditions that we were working in, really. So some of his findings, so obviously the graph there is representative. We have a control line on the left-hand side, which is in grey. So that is basically the cone penetrometer going through the soil, looking at the neutral point. And then we have the soil deformation and compaction from a Terra Trak, which is in green. And then orange one there is a 960 tyre, which would have been quite a common tyre on one of our combines back then. So when the Terra Trak was compared to the 800 tyre, the soil compaction was reduced by about 66%, and ground pressure, once going through the first sector, remains at about 0.8 bar through the soil structure. The study also showed that 65% of the reduced soil deformation, so versus the 900, and a depth between 10 and 60 centimeters. So as you can see here, once we get to the point, we can see that the tyre, although the Terra Trak puts probably more compaction in the top part, the tyre basically continues with compaction right down to the depth of 700 millimeters. So although the Trak, the Trak's main compaction is basically within the top 10 to 12 centimeters of the soil. So basically, and once we get down to 40 centimeters, there's very little compaction compared to the Terra Trak unit, compared to our control section. So basically, the compaction is kept in the top 10 to 15 centimeters of the soil, more or less. So so the other thing that they found was that soil compaction is close to the surface, so normal tillage applications would remove the soil, whereas with a wheeled machine, deep subsoiling would be required to lift the pan and so on from there. The other thing that they noted in the research was that the crawler tracks, because of the way that they can pack that top 10 centimeters or so, they leave a roadway, which they found that there was less effect with the rear tires running on where the Trak unit had run compared to a wheeled machine. So in terms of compaction, although there's still compaction with a tracked unit, the compaction's more manageable because it's at the top layer of the soil structure. So what does that mean for the customer? Well, basically, because we don't have to cultivate so deep, basically we can reduce the working depth of the implement that we're using to lift our compaction. Therefore, we need less fuel, we need less time, we could probably work faster, but also we use less power requirements. And I think the statement there, so the graph here is working depth of the implement and versus attractive power. Number one is subsoiling. So we noticed that once we've got to go quite deep to lift our compaction, our tractive power is increased quite significantly. So, and I think the stat there from the study is that basically a reduction from 240 horsepower to 88 horsepower and represents a 63% reduction in horsepower to remove the compaction. So, the Terra Trak really is proven technology. The Trak system works, especially as we get bigger combines, bigger grain tanks, and so on. But we go back to our flotation story. So, although soil compaction and obviously rolled soils are a consideration, we go back to our flotation story in that, unfortunately, soil compaction has to go out the window in certain harvests. So this is 2007 harvest, I think this is, looking at the combine. So we had a lot of growers that had a very, very difficult harvest. We can see here that rape stubble, we've got standing water in where the combine's been. And really customers in that harvest, and it sort of coincided with the research that Dirk had done the year before, so it was quite a good marketing campaign for CLAAS for sure. The big beast almost exhibited the characteristics of a hovercraft. So that was one customer. Another one said heroic, and another one said if we didn't have tracks, we would not have gathered our rape harvest. So from a customer's point of view, although they've bought the tracks for soil compaction and you reduce tillage benefits, this has been their insurance policy a little bit for those difficult harvests that we all have to go through from time to time. Hopefully we won't have 2007 again very often, but that's where we were. But unfortunately, even the Terra Trak does have its limitations as well. So, and usually if you've got as far as you can get with a wheeled machine, you usually got about 10 times further with a track machine and end up having a slightly bigger recovery job. So what are the other benefits to tracks, or other than the agronomic benefits, the reduced fuel consumption with the subsoilers and so on? We also have the benefit of having a stable platform. So as combines have got bigger, heavier, we've also gone to wider cutter bars. So not uncommon now to sell a big Lexion with a 45-foot cutter bar. The Trak takes away the tire swab. So when you go through ruts and so on, you don't get sort of a wavy side-to-side movement with the combine. A nice stable platform for the cutter bars to cut. So probably one of the biggest, or another big benefit for a lot of our users once they go up to, I'm going to say 35 foot and above cutter bars, or 10.5 meters, I should say, not feet and inches in this day and age. So 10.5 meters and upwards. We're now got a nice stable platform for the machine to run on. And the big benefit as well, as I touched on earlier with the early full Trak system, is that we're able to reduce the transport width. So on our standard body machine, we're down to 3.3 meters wide for transport, and on our wide body machine, we're 3.5 meters. So a real benefit, especially when you come to the west part of the country and the lanes and so on aren't very accepting of maybe larger machines. Your typical machine with a 900 tire on would be just under 4 meters wide. So we're gaining half a meter nearly for over a tired machine there. So and for us, the Terra Trac on the combine, yeah, it's 30 years of development. We're now on our third stage. A lot of our competitors are only been coming into tracks for the last 10 or so years. So we've have a lot of experience with our tracked machines. We've over 75% of all the, I'm going to call them hybrid combines, the bigger high output combines are now sold in the UK, particularly with Terra Trac system. Maybe not quite as popular for other markets in the world, mainly because they have different weather conditions, different soil types, different road conditions, and so on. And there's a full range of tracks, there's varying combines available both in our Lexion and our new Trion range, whether it's a straw walker machine or a big hybrid combine harvester. So moving on to the background. So our Trak units are made by CIT, CLAAS Industrial Technique. It's located in Paderborn. It's about 40 miles to the southeast of our main combine plant in Harsewinkel. This factory concentrates on most of our drive lines. So all the axles for the combines, whether it's a wheeled or a track machine, are made there. Gearboxes are made there. There's components for the hydro units. So it's a separate unit that basically manufactures components that feeds the main production plants. There's about 650 employees working there with about a £200 million turnover. And it's been part of the CLAAS group since 1957. So a long a long sideline there. It also builds our CVT transmissions for our Arion 5 and 600 tractors. So yeah, 2013 when the new Arion came, we also introduced our own CVT box, and so all that's done there. It also makes corn cracker rollers for forage harvesters, so a broad spectrum. But we also sell many of the components to other manufacturers as well, because some of the componentry is quite specialist towards agricultural machines. It suits us to although it feeds our factory, we might have a valve block that might be useful to somebody else's because they want to do the same function of it. For a manufacturer to build their own, it could be quite costly. So they pool on our valve block or whatever, and we sell that through CIT. So it's almost run as a separate company that either sells the bits back to the CLAAS factory or bits to New Holland or John Deere or whoever's buying them. And probably while we're talking about Terra Tracs, probably one of the ones that we might even see locally here because of the potato growers locally, is that we obviously supply Grimmer with the Trak unit to go onto their self-propelled potato harvesters, as well as cab units and other units as well. So that's where the Traks are made, and again, it's a partnership with many other companies, not just supplying our own factory. So moving on, probably our later development and more where we're focused tonight really is that is our is a move towards making a Trak tractor. So this is our Axion Terra Trac machine. I think we probably saw the benefit from some of the things we've seen with the combines and so on, and decided to go into using some of the componentry to build our own tractor. So it's not the first time that CLAAS have been involved with Trak tractors. Even before I started with the company, obviously the Challenger tractor was marketed in the UK with CLAAS badges on it. Obviously, partnership started in 1997, and then, like I say, just before I started with the company, the partnership finished. So 2002, when AGCO was AGCO purchased the Challenger brand. So obviously the green tractors, the two tractors, quite a good partnership for us at the time. High output combines, high output pulling machines, and probably more so in the UK than many other markets in the world. We're probably quite ahead of the game in as far as Trak tractor sales went. It left us a little bit of a hole. So that came and went, and then obviously we had a little bit of a flirt with a half track system there on the right hand side. So that was a stocks agri track. But it was, the original concept was designed by a Leicestershire farmer, a H Trak, I think he called it. He then sold his design rights to Stocks, a company that make dual wheels and componentry over in Cambridgeshire. And latterly it got sold to the business, or the Trak side of the business got sold out to John Deere. So a little bit of a short-term partnership for us, but I think this unit around 2004, 2005, literally, I remember seeing it at Cereals the year before I started with CLAAS, doing demo tours and so on there. So again, it's not the first time that we've been involved with Trak tractors, but I think the decision was to try and offer something back into the Trak sector again. So why did we look back into the Trak system? Well, we got various people retrofitting Trak systems to our tractors. Definite focus for when we get to these, I don't know, 300-400 horsepower tractors to get the power to the ground. Conventional tractors with dual wheels on is probably in Europe and certain markets of the world has been the way to go. Again, for the UK, this is very limited transport width and so on. But when we started putting together the concept of the Terra Trak machine, really we wanted to have similar driving characteristics. So basically you could jump in one of our Trak tractors and it would drive very similar to a normal wheeled tractor, and also be able to drive at 40 kilometers an hour on the road, still weighing 22 tons. Whereas with particularly with a wheeled machine, obviously, if you're changing tyre pressures, sometimes you can't carry the ballast at the same tyre pressures that you want to work in the field at. So for us, there was some call it prerequisites when they were developing the half-track tractor. So the first concept one looked very much like this. It was first tested in 2013. It actually used a smaller tractor unit than we use today. So this is actually an 800 unit underneath, and which is what, 200 to 280 horsepower roughly. So under 300 horsepower sector. So it was tested across Germany with a full set with full Trak tractor customers. So 2 Trak tractor guys. So they homed it with several to get feedback and to decide where we were going with the feasibility of the project. The feedback was that compared to a wheeled tractor, it was much better for traction on hills. Again, probably because of side loadings on tyres and so on. The additional grip in a straight line was fantastic because of being able to use a 4-wheel drive front axle, where a 2-track tractor tends to suffer is basically if it loses grip for any reason, if the soil's a bit is a bit slippery, and there's no way of being it because you're steering with the track units. There's no way of basically locking the two together. So so one of the advantages of going down the half-track route is that we gain the front axle, use of the front axle for traction as well. Good driving comfort. So we have a Gen 3 Trak on there. So this was literally a combine track on the early concept. It was literally a combine track that got bolted to the tractor. And obviously, there's been some development move on there, which we'll look at in a minute. And they decided that 200 to 300 horsepower was not enough, that we needed, if we're going to put this concept to market, that we needed to increase the power significantly to make use of the tractor. So the concept went to the board, and basically it was born. So we took our existing Axiom 900 tractor up over 400 or up to 400 horsepower plus, and basically made some adaptations really. So we put 40k maximum road speed on it. So where the wheeled tractors for the UK market anyway are 50 kilometers an hour maximum road speed, for the track unit 40 kilometers an hour, but that's pretty much in line with anybody's tracked system already. We retained some of the key features from the CLAAS tractor, like the 4-point cab suspension. We've now got a suspended track on the back. We've got our front axle suspension, which we retain from our wheeled tractors. So basically those were the bits and pieces. So what did we do? We put, to make it into our half-track tractor, we added the Terra tracks. We've obviously had to move the fuel tank and many of the auxiliary componentry to fit the tracks around the tractor. A completely new transaxle, which we'll look at in a bit further, and obviously changed the access into the cab because we've now stuck a track unit onto the back. So in terms of the rear axle, on the left, what we can see is the original wheeled tractor axle. So what we did, we removed the rear trumpets, and we've actually incorporated what they call this saxophone drive unit. So to allow the tracks to fit to the tractor, rather than just unbolting the hub and bolting a track unit to the actual hub of the tractor, we've actually engineered a complete framework so that the track bolts on and it keeps all of its functionality that we would expect from maybe the combine harvesters and so on. The tracks are also shaft driven, so we needed to make provision for driving a shaft rather than driving out of a hub and a reduction unit and so on there. So a completely new engineered rear axle to allow us to make a tractor. And obviously just in a bit more detail there, so we can see that the shaft mounts through the center of the section. We've actually moved the track axle and so on forward to make it marry up with where we want to we want to be in the system as well. So the other thing that it allows us to do, it's actually got a slightly smaller, shorter wheelbase compared to a wheeled tractor by moving the pivot point of the transaxle to the for the track unit. So in terms of the suspension, obviously we used the concept of our Gen 3 Trac, but because of the terrain that the Trac tractor is likely to drive over, basically we looked at ground following and suspension. And hopefully, so we can see the movement within the axle undulations and so on. Again, we have a pivot point in the center of the track there, so we can allow us to go over ridges and so on, and that all the idlers retain contact on the ground, even if we're going over undulating ground. Probably one of the issues with a traditional 2-track tractor is that you tend to, because of the way the track runs on the ground, you tend to only use parts of the track in a undulating situation, really. As you saw there, the suspension system, very, very similar to what we use on the combine. So it's common components to what we would have used for a number of years, really. So to adapt it onto the, so again, to take the track from the combine and put it onto the tractor, what did we have to do? Well, we've put a bigger drive idler on the back, one for a bigger contact area inside the track, so that we, because obviously we're on friction drive, we need to wrap more of the belt around the back wheel to give us the traction. We've also reinforced the drive lines inside the track, because where a combine is carrying the load, so the track is purely there to support the load, only a small part of it is to do with actually propulsion of the machine. In a tractor like this, where we've got high draft forces hitched to the rear, we then have to think about how we're going to transmit 450 horsepower back through the drive lines to it. So we had to increase some of the gears and so on inside the track system. And also what we did, we changed how our roller was made. So on the combines, you will see that there's a solid roller. On the tractor, we use this spoked rim. Basically, the concept is that with a tractor, we're more likely to be going into muddy conditions. We might be on fields that have already been pre-cultivated or on loose soil, and so that we have a better cleaning characteristic inside the track unit for keeping the track clean. One of the other things we had to do, so because of the bigger diameter of the rear wheel, we actually lost a little bit of contact area underneath the track. So we have actually a shorter ground length on the track. So and that, as I say, purely because of the architecture for getting the bigger back wheel. But again, we still have up to, on the wide tracks there, 3.13 meters squared of ground pressure contact area. So the new wheel, we basically can alter the widths of the tracks by changing the size of the unit. So pretty straightforward as far as the manufacturing concept goes. Because of the gaps and so on, there's a lot more, call it airflow, so better heat transfer across and we have more surface area in the actual rubber block itself. If for whatever reason we do wear one of these pad units off, we also can replace them more individually rather than having to retread the whole wheel. And obviously, as I've said already, we've got this self-cleaning ability inside the track unit for soil and so on to escape, really. So how did we test the different track units and get to the conclusion? Well, someone came up with the idea of getting a bobcat, and someone obviously had hours of fun on a concrete yard somewhere, and literally we put the traditional Trak roller on one set of wheels, and we put on the opposite, we put the new style Trak unit, and someone obviously spent weeks driving it across the floor to decide how they were going to what the wear characteristics and so on were for the new thing. So quite a lot of work's gone into the redesign of the Trak unit for the Trak tractor, really. So in terms of the tracks, another prerequisite was that we wanted to retain under 3 meters transport width, regardless of the width of the track, which clearly we've done. So on the left-hand side there, we have our wheeled machine. So 900 tire at the top there is bang on 3 meters on our conventional tractor. And we are, even with a 890 mil track, we are still well under the 3 meters transport width. So pretty important for the European market, I would say, is that we do that. They do also offer tracks relevant for row crop work in American markets and so on there. So as far as the pivot goes, we're also, with having our center pivot here, we're able to pivot the track. So we've got an 8-degree forward pivot and a 15-degree upward pivot, again, to keep maximum ground contact when we're on undulating products. And that's something that's pretty unique to CLAAS. A lot of the other half-track tractors in the marketplace have got fixed track units, so you don't get the flexibility of the undulating the ground adaptation, really. Also helps with the comfort from a driver's point of view. We also incorporated I call it an automatic braking system as well. So we can actually, we call it steering assistance, but basically we can set a medium, strong, or a manual position for in the cab of the tractor, and basically as we start to turn a corner relative to our speed and so on, we can apply a braking force to the inside track, so it improves our turning radius of the tractor, just to give it a little bit of help when we're turning corners. One of the other features, like on the combine, is that we basically we can set 3 different working heights. So depending on the implement on the back, we may want to line up to try and get the best line of tractive effort, really. So again, we got 3 positions there, all functional from the cab. So that's where we're at. So really, for us, the 900 TT compared to a full track tractor, we got with 4-wheel drive, hopefully less slippage, less fuel consumption, less soil compaction, because we're actually got better ground following with the track unit. And yeah, as far as a wheeled tractor goes, because we've got front suspension, cab suspension, we can keep the comfort of a standard tractor. We've obviously got a CVT gearbox in there, so it's just like driving pretty much our standard Axiom 900. We've got Isobus, all the usual components to talk to the implements and so on. So and again, against a wheeled tractor, good grip and stability in hilly conditions, really. So so yeah, that's the Terra Trak concept on a CLAAS tractor, really. We have got another CLAAS tractor, the Xerion, that was never going to have a set of tracks on, has now got a track. It's not really something that we're focused on in the UK market. The tracks obviously come from a third-party supplier, but it's another offer in the Trak tractor product range, where, you know, Xerion up to 530 horsepower. Really, to get the power to the ground, we've either got to go to big single tires, 900 plus. We've got to dual it up, or potentially go down the track route as well. So the Xerion has grown tracks as well. So as far as tractors go, what does the future hold for Terra Trak? Well, 1 or 2 autonomous tractors are starting to enter the market now. So Horse are already buying a pretty familiar Trak unit offers to evaluate their autonomous project. And we have actually CLAAS themselves have purchased a minority stake in a Dutch company called IAgrE. Is it, do you know? IAgrE. And they've developed the AgBot autonomous tractor. Okay, it hasn't got a CLAAS Trak unit on it there, and I'm not saying I don't know the ins and outs of it, but the collaborations there that they can bring some pretty good technology to us as a manufacturer. Some of their diesel electric drives and so on that we've maybe not really ventured too far into, and we can supply them potentially with common off-the-shelf components that are already commonplace on our machines. So yeah, potentially we're going to see Terra Trac for quite a number of years as far as our tractor business goes. So I'll leave questions to the end. We'll do them all together, and I'll hand over to Dean to tell you about his big toy.
So the forage harvester range is really the last product in the whole group for CLAAS to actually have Terra Traks fitted. The development started actually a lot longer ago than you might think. So the first Terra Trak machines were actually built in the 90s, even the early 2000s. So CLAAS used to have a special vehicle division. So they used to custom build things. We would know it internally as a field shuttle. If you go on the internet and you look to places like Denmark or Belgium, the Netherlands, a lot of the customers that run forage harvesters are very limited in what they can do in the field. They can't take road machines into the field. So that's where a field shuttle was born. So you actually have a forage harvester with a bulker on the back or a lorry container. Those machines were built with Terra Traks years and years ago. Also, when we launched our new 900 series of foragers in 2007, one of the first projects for that new machine was to stretch it to see how feasible it was to run a full production series of Terra Traks. The big difference between a forage harvester like you see here and a combine, though, is what's working beside it. One of the reasons foragers are taking much longer to come onto tracks is because of the tractor and trailer it must have beside it. So where you see combines, like in the pictures Cole showed you earlier, great for reducing compaction, and most of the time the combine can work up and down the field on its own. This one looks lovely, sexy with its tracks on it. It goes nowhere unless there's a tractor and trailer beside it. So you develop the forage harvester to reduce compaction. You spend a lot of money to try and have that process, and then someone comes in the field and they're running 385mm wide super single tires, and he's completely undone all the benefit that you have done with your forage harvester. So some markets are already seeing a huge increase in sales in Terra Traks because they're already a long way ahead of the UK when it comes to trailer technology. So a lot of our customers in the UK think that a 560mm wide tyre on an 18 or 20 ton trailer is a flotation tyre. If you go to Europe, they'd laugh at you. They'd see 600, 710, 800 tyres. They'd be 26.5-inch diameter or 30-inch diameter. They'd be tri-axle, powered axles, and air tyre pressure kits. So the trailer almost does float on water. And when you have that sort of technology, it then brings along the question, why not put it on the forage harvester next? So the UK, I brought one over for this season to do some demonstrations with, and it really opened up a lot of customers' eyes to see the difference that made in the field to compared to their trailers, what the mess they were leaving in the field. So what do we have? Two models available, a Jaguar 990, that's our flagship machine, that's a 925 horsepower forage harvester, and we also have a smaller 960. So why do we have the two models? Well, the simple way to look at it, the markets that really demand the tracks are the markets that do a lot of maize. So in simple common language, the 990 is your 12-row maize machine, so a 9-meter maize header, and the 960 is your 10-row maize machine, so an Orbis 750, for example. And also it avoids a lot less complexity on the production line if we just have two alternatives as opposed to possibly 15 alternatives that have the tracks on at the moment. One thing that is different with the track machine compared to the wheel machine, Cole mentioned it earlier, the Terra Traks are designed to fit on potato harvesters, tractors, combines, all that operate at a much higher weight than the forage harvester does. So because of that, the Terra Traks are actually geared lower than a standard wheeled machine. So because they're geared lower, they drive slightly different in the field and on the road. They're still 40 kilometers an hour, as you see here, but the difference is when you put the thing into field mode, it's noticeably slower than where a wheel machine is. So in first gear, you're about 15 kilometers an hour, whereas in a wheel machine, you'd be 25. And the same when you get on the road. This machine does it at 1750 revs, whereas a wheel machine does it at 1300 revs. You hardly hear the engine in a wheel forager at 40k. Next up, again, just like Cole said earlier, track width. So the machine that's very popular in Europe is the standard 630mm tracks because it's 3 meters wide. And the same with all our front attachments. Going down the road, it's ever so narrow. Doing the demonstrations over the last couple of weeks, that's half a demonstration or half the dream sold to the customer. It's actually how easy it is to get to the field. Many of you have driven a tractor or something wide before and you meet a car in a narrow road. Sod's law, the car will always pull over by a tree or a telegraph pole, something you can't get past. One thing you really notice with a narrow forage harvester at 3 meters, you get almost everywhere and you do it almost full racing speed as well. Taking the demo machine around, I could go in front of a wheel machine and I could easily get to the field maybe 15 or 20 minutes before them because I haven't had to wrestle with a car and caravan that can't go backwards down the country lanes. So transport width on these machines really is a big benefit because it is very narrow. 3 meters is the width of the body of the machine. When you go to the US, a surprise big sales market for us with Terra tracks. So when I sat in our product management meetings about Terra track development for forage harvesters, the US was the first market to say waste of time. As Cole mentioned earlier, they can run down the road with a 12-meter header on the front of the combine while they're concerned about going from 3.4 to 3 meters wide. The big advantage AC, and just like Colin said, is stability. So if you ever look at pictures in the US in particular, a center pivot irrigated fields, great things for growing yield, but also great things for leaving massive ruts in the field where the wheels go around. So often in the US, you'll find dual wheels even on a forage harvester for stability. So it keeps the machine lovely and stable, the header doesn't move around, so therefore the stubble's a lot tighter. One thing we actually had proven with our demo machine this season, there's a measurable difference in the yield of the crop in the field from a Terra track to a wheel machine. So take, for example, my 9-meter Orbis. When I was using that machine in the same field as a wheeled forage harvester, regardless of the color, you'd probably see anywhere from 0.3 to 0.7 tons an acre more for your maize than you would do with a wheel machine. Depending on who's drilled it or ploughed the field before it, that figure could exaggerate even more. So you imagine as you're going across the field and a wheel drops into a hole, so does the header. The header often will slam in the ground, auto contour corrects it, or if it goes over a ridge, it lifts it over the bump and you see a much longer stubble. So you can actually see a target stubble height of 100 mil, and you might actually some of it's 300 mil long because the guy's going too fast and it's very rough. With a Terra track machine, it was absolutely planted. There's no movement in it at all, apart from when the rear wheels drop into the rut. But like we measured earlier, there's a nice little roadway that it creates. So even driving across maize rows or across tram lines, the machine is incredibly stable. So the first thing you notice, even after 2 or 3 days of demos with my forager, there's still paint on the underneath of the wear skids of the header. In a wheel machine, they're gone in the first 10 foot. So very stable, much higher yield. You could argue, especially with a maize plant, the bottom part of the maize plant, maybe the bottom 100 to 150 mil, a nutritionist would say there's probably not a lot of goodness in it, and I'd agree. If you ever fancy eating a salad, you only eat the leaf, you don't eat the bit underneath of it. But also depends on the perspective of the customer. Say, for example, Cole's growing a field of maize and he's going to sell it to me for my biogas plant. Cole would take the root out of the field if he could do because it adds more weight. From my point of view, I don't want that. I only want a better quality type feed. So the guys that are selling to a biogas farm or to a dairy farm get paid in tons. And Terra tracks mean more tons because the cutter bar on a combine or your Orbis maize head is more consistent, shorter stubble. Again, one of the reasons it's so popular in the US, where they're very heavily maize dominated. 3 meters on the road, like we said earlier, nice and nimble. And again, just like it is on the tractor, it's fully suspended. So it's a nice smooth ride on the road as well. So when you actually look at the track unit itself, the front roller is the tensioning system. That's what the hydraulic cylinder does. It pushes the roller forward. And the middle wheels, the 2 idlers there, actually push down. But it's a combination of the two that allow the 3 out of the 4 rollers to all move. If you hit manholes, you go over the little islands that the council build in the middle of the road for you to cross over, potholes, for example, it means it's incredibly stable. And if you're brave enough when no one's coming, you even notice a difference on roundabouts as well. Where a tall machine 4 meters high for a forager or a combine, for example, will wallow if you go around a roundabout too fast or across the side of the hill, the tracks are incredibly stable. No different than a boy racer with his lowered car, very little sideways movement. So again, cornering speeds, much faster, much more stable, and especially in very steep fields. That's one thing we noticed with the demo machines, and you see it with combines. you're very reassured, even on steep ground, it will go backwards, it will go forwards, it will go through the wet spot. So again, it means it's a lot better performance in the field. One very clever system that's unique to the forage harvesters, though, is what we call headland protection. So if you harvest your field of wheat or your field of rape, for example, your maize or your whole crop, typically you're going to go in the field and rip it all up and make it brown afterwards to put the next year's crop back into it. So the scrubbing that you see with combines or with our Trak forager isn't really as important when you're growing maize. However, when you're growing a field of grass, the last thing you want to leave every time you turn on the headland are the ruts or the scuffs that you'd see from the Trak units. So the unique thing that we can achieve, especially with the hydraulic suspension you see on the Traks, is the little unit you see here. So when the machine has a grass header on, it knows the header from the little module on the front of it, so it instantly recognizes I'm picking up grass. As soon as you turn the wheels past an angle that you've set in the cab, so maybe 5 degrees, for example, it does this little party trick, which is this. It forces the 2 IAgrE rollers down and effectively picks its toe off the ground. So instead of turning on the full length of the track, you turn on roughly 60% of the track. So 2 big benefits. Benefit number 1, when you turn, instead of ripping all of this area here, it's only this much shorter section, which is not a lot different than a tyre with a lot of air let out of it. The other big advantage with it as well is the maneuverability's increased a lot because the wheelbase has got a lot shorter. Instead of the machine pivoting around here when it turns on its rear axle, it now pivots around this part you see just here. So a measured turning circle, a Terra Trak forager with a maize header on and a flat track is 19 meters. A measured turning circle in grass mode is 15 meters. So it's 4 meters off the turning circle just by pushing the idler roller down and lifting its front toe up effectively. Just like you saw with combines, they are tried to go in boggy conditions. This is one of the reasons, especially in Northern Europe, if you take Denmark, Belgium, the Netherlands in particular, for example, a lot of their fields are sea level or below it. So when people in the UK complain about it was a bit of a wet harvest and a quarter of the field's wet, if you go to those farms, often the whole farm is wet and it looks just like this. That's why they have powered axles on their trailers. So the big advantage with the forage harvester is it's designed to climb and climb more so than the combine is. So underneath the front axle, it's all re-engineered. It's much stronger and heavier in the chassis to cope with the extra stress that a Trak puts on it. But it also has these cast lock stops, top and bottom, that allow the Trak to do that. It allows it to climb. So if you imagine the tallest tires that we fit on a machine are just over 2 meters tall. So halfway up is a meter. That's roughly where you're not going to climb out of a hole anymore. But to be honest, if you're a meter in the hole, you've got far bigger things to worry about. A Trak unit roller is considerably lower, probably down here somewhere. So again, probably half the height, if that, of where it can actually climb out of the hole. So the bit that really helps with the forager in particular is the fact that we can angle the track up, it sits on its lock stop, like you see here, and it climbs out of the hole, as opposed to having the track sat flat and it just buries itself into it. And that's not stuck, that's still going through. So forage harvesters also benefit from a limited slip diff in the front axle, so it's locked and it can keep going, and also 4-wheel drive. This is all part of the testing and development we've done over many years. So this machine really is very capable of working in wet conditions. You'd argue you shouldn't be there, but also when a customer spent a lot of money growing his field of maize, for example, he will also argue you've got to get it out of the field. So as much as you do a huge amount of damage, and I wouldn't like to say what you're going to grow in here afterwards, if a silage trailer gets stuck, that's possibly 1 machine out of 4 or 10 that's out of action. If this machine gets stuck, everything stops. So again, something we've really shown on the demonstration tour just recently, I was in the field with a wheel machine that needed a digger, and 4 hours later, it was out of the field, my machine, nimble as anything, cut all the way around it, and didn't make a mark. So again, on that day, we could soon justify the tracks because we didn't need a digger to get ours out of the mess that machine was in, similar to this. When you look at the machine, it's very different than a combine or the tractor and the amount of adaptation we need to get the tracks on it. So the forage harvester chassis is stretched to put the track unit on it. It's just over 1 meter longer than a standard machine. The big noticeable difference is what we call the maintenance bay in the back of here is massive. So that's where you see the extra length. It's 1 meter longer in where the corn cracker would go, for example. So for daily maintenance is also very, very easy. The corn cracker unit goes in across the top of the tracks as opposed to going in between the cooling system and the fuel tank. So again, serviceability on the machine is also a big benefit for having the tracks. To prove what it can do in the field, again, more comparisons, more studies, this time with a university in Germany, where they actually looked at the ground compaction and also almost the scrubbing effect you would see on a track machine compared to a wheel machine. And importantly, in a field of grass. That's where you really get the questions, or I've had the questions, what's it going to be like when I put a grass header on the front? So when you look at the contact area of the machine, if you look at probably the widest tyres we sell in the UK would be the 800 tyres. This gets the machine to 3.3 meters wide. A flat track is well over double the area, so a huge amount of area on the floor. And again, it's only 3 meters wide. Even when it goes into headland mode, you're still substantially more surface area with the track with its powered rollers down. And that's what you see here, the different areas. So you see a flat track, a shortened track, and an 800 tyre. So a big difference you see visually just there. And then we look at the ground pressure. So again, graphs you've probably seen many times in lectures. The one thing to really look at here, this is our wheeled machine, front tyre and rear tyre loads. This is the track machine. Anybody know why there's so many peaks on it? What?
It's because the rollers and the wheels are causing peaks.
You got it exactly. So technically, a forage harvester, a flat track forager, has 5 axles. If you put the maize header on it, it has its own lowered hydraulic wheels. It has 6 axles. The other advantage as well, certain states or counties in Germany in particular have very tight axle weight laws. So now we've gone from a forager with 2 axles to one with 5. So you can actually get away with carrying even more weight through some areas where we're very limited on the size of the headers you saw before. But the real thing to notice on the graphs, you see the wheel machine with its big tyres, well over a bar on ground pressure. If you look at the front wheel, the 2 idler wheels and the rear wheel, almost less than half what you are with the big front tyre. And you see the rear load for the tyre here, less than it is for the other wheel machine. Now, the bit to really look at here, the wheel machine's running 620mm wide rear tyres. The Terra Track is only running 500s. The reason we put 500s on it is to keep it all narrow. That's 3 meters wide. You can still put the 620s on, but effectively then it's tapered in the wrong way. So the back is a lot wider than the front. If you've ever driven one of these machines and get yourself against a curb, if the back is against the front, it's actually very difficult to get yourself off of it. Otherwise, you have to bounce up over it to get through again. But even because the machine has its longer wheelbase, and by the fact we put our little trackway in first, when you actually measure the ground pressures, even those smaller real tyres are actually putting less load in the field than what we saw with the wheel machine. A comparison we did is at full lock, so 15 meters to try and get around to a 15-meter swath with our biggest ball rotor rakes. This is the test. You see the little probes in the ground to measure it as it turns. You'll see the difference, even with the track shortened up, it still puts a lot less ground pressure in the field than what you find with the wheel machine you see over here. But the important thing that customers want to look at is how much damage is it doing to the soil or the grass effectively. This is your wheel machine, this is a flat track, this is a shortened track. You see the difference between a shortened track and the wheel machine, you'd argue, yes, you still see a difference. But if you actually took, for example, this entire screen as a field, you only really see this in the 90-degree corners in the corner of the field. When the machine's turning on the headland, it's very rare every single driver takes the next bout or the next pass. Typically, you skip one, you maybe even skip 2. So the only tight corners you really see are here in the corners. If you were to come down, go across and back up again, you probably miss one pass. So again, when you see the damage in the field by shortening the tracks, it's very marginal and only located really in the corner sections you see in the field here, for example. Again, that really highlights the big difference. And when you actually see a longer grass, or actually the pictures in detail, there's quite very little difference between the shortened track and the tyre machine. Again, if you take the machine, depending on ground conditions, when you go up a grass field, especially the ground's very hard, the wheel machine makes more of a mess as it scrabbles to try and get over. The track machine has a lot more traction and soon pulls itself up the field and turns a lot better. Again, here's our big sales argument that we'd always argue with customers. People like having the big fat tyres because it's better for traction, better in wet conditions, looks a lot better to some customers, but you always struggle with road width. 3.3 meters doesn't sound wide compared to a combine, but where you see the foragers operating on the west of the country, 3.3 meters often is a problem. There's still farms I go to with demo machines and they don't even have 3.3 meter gateways to get through. When you see the wheel machine, the track machines, massive contact areas, a lot less ground pressure, and you're 3 meters wide. So a big benefit over what you'd find with a wheel machine. So in summary, the new sort of feature with our forages, 40K for tracks, full hydraulic suspension on the front, and the fact it does this little party trick of lifting up its toes when you turn around means it really is usable in every single crop, every single condition. So again, the last machine to join the range, but it does have a lot of nice highlights to really use it in all conditions and also keep it completely unique.